Everyone, welcome back to Pine Hollow out of Diagnostics. We're doing a field call today. Got called out for a 2004 Nissan Frontier V6. Apparently the owner, he bought it. He ran for 4 days, then stalled out, done, dead in the water. He says it has no spark, so he replaced the distributor. There's the original unit. I'm guessing that's the original unit. And again, also the crankshaft position sensor that lives on the bell housing. Nothing. Still no spark. So he called me out. He says it's setting some kind of camshaft position sensor code. But yeah, let's scan it for codes and do this one from scratch. Here we go. Alright, here's our brand new distributor and 6-pin connector there. So let's scan it for codes and get some service info. Alright, so here is the code scan. Sure enough, we have a P0340 cam sensor circuit bank 1, and on these older trucks the distributor with the cam sensor built in is everything, so with that code it's not going to start. So that's good. We have a direction. Looking up the trouble code, see component description. This has an optical, see LED light emitting diode, photodiode right here, and it has this plate with little notches in it. So we have 6 notches here, and then a wider notch for synchronization to cylinder number 1, and then 1 degree signal slits on the second, I guess the outer perimeter. So camshaft position sensor is a basic component of the engine control system. Monitors engine speed and piston position. These input signals to the ECM are used to control fuel injection, ignition timing, and other functions. Cam position sensor has a rotor plate waveforming circuit, 360 degree slits for 1 degree, that's the POS signal, and 6 slits for a 120 ref signal. The waveforming circuit consists of LED diodes, blah blah blah. So I want to know during cranking what the signals are supposed to be. So this code can set for either the 1 degree or the 120 degree notches, not signals not sent to ECM. And let's keep going here. Okay, here's the wiring diagram. So there's the POS and there's the ref. Light green, purple wires, pins 3 and 4 at the distributor. That's the easiest place to measure those. We will need an oscilloscope. And oh, check this out. They actually have known good waveforms, what it's supposed to look like. Excellent. So reference signal, position signal. This is the 6X, this is the 360X. So we'll use 2 channels. We want to make sure that we have power on pin 4 with the key on. That would be this, let's see here, 43 VB. There's the ground. Oh, this is the ECM pin, okay. Here's the non-OE diagram. So pins 3, 4, 5, and 6 looks like come from the camshaft position sensor. So let's measure at least the 5 volt and the ground first, and then we'll put a scope on the 2 signal wires. Okay, so the first pin I want to check is pin 6, this black and yellow wire. So probe is in there, test light from battery positive. It finds a ground. It's going to light up. And this pin, yep, the ground is good. So that's 1 pin. Now let's go to pin 5. That would be this black and pink. Turn the key on, and that should be a 5 volt reference. So actually that pin is 13.5 volts, and well, the test light even lights up the test light. So that is 12-volt reference from the engine computer. It's not a fused circuit. It actually comes right from the engine computer right here. This black and pink wire, VB. And also, let's see, black and pink wire right there goes to ECM relay. Okay, so when the ECM relay closes, that is a feed from the relay through that fuse. So we're good there. We have a good supply, good ground. Now let's get a scope on the 2 signal wires, crank this thing over. Alright, we got 2 channels hooked up. Channel 1 is on pin 3, purple wire, that's the reference. Channel 2 is on the light green, that's the position, 360 per revolution. So let's crank it and see what the signals look like. Alright, here we go. Scope is rolling, key on. Crank it. Okay, sounds like the timing belt snapped.